There are two ways to solve quadratics when they don't factor. One of them is called completing the square, which you know, and the other is called the quadratic formula, and that's what we're going to do today. And really, it's just the same thing. You'll see that in just a second. This first one actually does factor, but we'll use the quadratic or the complete the square method anyway. So if I move this over, x squared minus 7x, leave a space, equals 78. What number would go in my factor? 7 halves, negative 7 halves. So what's my perfect square? Plus 49 fourths. Does anybody not understand that? We're good there? Okay. So I add 49 fourths, and I don't know what that is in my head. So 78 plus 49 fourths. Oops. 78 plus 49 fourths. 361 over 4. So I square root x minus 7 over 2. Is 361 a perfect square? Yeah, which one? 19. So plus or minus 19 halves. I'm going to add 7 over 2. Add 7 over 2. 7 plus 19 is 26 divided by 2 is 13. 7 minus 19 would be negative 12 over 2 would be negative 6. And those are the roots. Okay? All right, I believe the next one is not going to be so nice. X squared plus 8x, leave a space, equals 15. So my factor is x plus 4 squared. So my perfect square would be 16. 31 square root. X plus 4 equals plus or minus. 31 is prime, so it's not going to simplify. Root 31. Subtract 4. And my answers are x equals negative 4 plus or minus the square root of 31. Okay, but those are both real numbers. They just happen to be decimals that are irrational. So they go on forever and they never repeat. The next one, if I did it correctly, should be imaginary. So x squared plus 10x, leave a space, equals negative 40. My factor is x plus 5 squared, so my perfect square would be 25. This equals negative 15. Square root. X plus 5 equals plus or minus. 15 is made up of 3 times 5, so it doesn't simplify, but we'll have an I. And then I subtract 5. Negative 5 plus or minus I root 15. Later on in this chapter, I will show you what imaginary roots mean on a graph, but we're not at a place where it will make a lot of sense at the moment, so I'm going to skip it. Right, take a look at the worksheet I gave you. And we're going to complete the square again. So x squared minus 13x equals negative 42. What is my factor? Minus 13 halves. So x minus 13 halves. What would my perfect square be? 169 over 4. Plus 169 over 4. So negative 42 plus 169 fourths is 1/4. plus or minus 1, wait, not yet, 1/4. Square root, square root, square root, and I get x minus 13 halves equals plus or minus, what's the square root of 1/4? 1/2, 1/2. Then I add 13 halves. 13 plus 1 is 14/2 is 7. And then 13 minus 1 is 12/2 is 6. So my answers are x equals 7 and x equals 6. Now, when we complete the square, we do the same series of steps every time. That's called an algorithm. Whenever you set up a series of steps and you follow those steps one at a time, we call that an algorithm. Well, because it's the same series of steps regardless of what the equation looks like, we can actually take a generic equation, an equation with no coefficients, just variables, and we can complete the square on that equation, and it will turn it into a formula. So what I'm about to show you is probably going to go over some of your heads, and that's okay. Just follow along, write it down, and I haven't even shown it to you yet. So if you don't understand what's going on or how to recreate it, that's okay. But I made it to some really high-level math classes at BYU before I saw this, and it would have been nice to know at some point. So bear with me. Okay. Well, I'm tired of completing the square. And sometimes completing the square is really terrible, especially when there's a number in front. So we're going to create the quadratic formula. So my equation is now ax squared plus bx plus c. And I have no idea what a, b, and c are. In fact, they could represent any number on the real number line. Okay? But I can never complete the square if a is anything other than 1. So I'm going to go through and divide by a. So I get x squared plus b over a x plus c over a. Completing the square does not work if there's a leading coefficient. Okay? Well, now that I'm at this step, how do I complete the square? Move the c over a to the other side. So I'll have x squared plus b over a x, leave a space, equals negative c over a. Now my factor will be what? Half of b over a. How do you cut a fraction in half? Double the denominator. So it's now b over 2a. If my factor is b over 2a, what would my perfect square be? B times b, which is b squared, over 2a times 2a, which is 4a squared. So I'm going to add b over 4b squared over 4a squared. Now, here's where it gets a little bit tricky. What do you need to have in order to add two fractions? Common denominator. So if one of my denominators is a, and my other denominator is 4a squared, what would my common denominator be? 4a squared. So my second denominator is actually the common denominator, so what does my first denominator need? A 4 and an a, another a. So I'm going to times this by 4a over 4a, which is going to give me, and I'm going to turn these around just because that's the way we write the formula. So I have b squared plus, what does this become? It's actually minus. Sorry. B squared minus 4ac over 4a squared. And that's the step that usually confuses people, but trust me, it's mathematically sound. So now this equals b squared minus 4ac all over 4a squared. Now what? Square root. So I square root the top and the bottom, and I get x plus b over 2a equals plus or minus the square root. Well, can I square root b squared minus 4ac? That might not be so obvious, but let's look at something. If I had the square root of 16 minus 4, is that the same as the square root of 16 minus the square root of 4? Can I split those up? Well, 16 minus 4 is 12, so this one is the square root of 12, and this one is actually 4 minus 2, which is 2. Are those the same numbers? Not even close. So if you have a polynomial with more than one term, under a square root, you can't simplify it. So this negative, the b squared minus 4ac, there's nothing we can do. But I can square root 4a squared, 2a. And then I'm going to subtract b over 2a, and I'm going to put it in front, negative b over 2a. And they happen to have the same denominator. So the quadratic formula right here is negative b plus or minus the square root of b squared minus 4ac over 2a. You're going to need to memorize this formula. And just because we like knowing things that stay in our head so we can't sleep, we're turning to YouTube. Okay. You ready for this? This is the quadratic formula put to the music Pop Goes the Weasel. Yeah. It's going to keep you up at night.
Quadratic formula's negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yeah, we need to do that again.
The quadratic formula's negative b plus or minus the square root of b squared minus 4ac all over 2a.
There was another. Oh, this one's quality.
Okay, we're recording.
I can totally see the Logans doing this. Okay, now you've got it memorized, right? So, this formula will complete the square for us. So we took a generic equation that represents every possible situation, every possible quadratic. We completed the square and came up with a formula, and this is just x equals. So all you have to do is plug in the numbers a, b, and c, and it will do the work for you. It will complete the square for you. So whether you complete the square or you use the quadratic formula, you're doing exactly the same thing. One of them, you just follow the algorithm, and the other one, you just use the formula. So, let me lock this, get rid of that. Oops, that didn't work. Okay, well, whatever. So in this case, A equals 1, B equals negative 16, and C equals 48. One word of caution about completing the square. I would never, ever complete the square if there's a leading coefficient. If A is not 1, don't complete the square. Completing the square is actually faster and a little bit more reliable whenever A is 1. But if A is something other than 1, use the quadratic formula. So, we're going to plug it into the formula. What is negative B? 16. So 16 plus or minus the square root B squared. Now here's a word of caution. If I typed in negative 16 and squared it, I'm going to get the wrong number. What is negative 16 squared? 256. Why did it give me negative 256? Right, it's following order of operations, which says that subtraction comes after exponents. So it squared it and then made it negative. So you either leave the negative off or you do this. And it will give you, give you the right number. So 256. Now I have minus 4 times A times C. So in your calculator, this is what I would do. Negative 4 times 1 times 48, which is negative 192. Over, what is 2A? Just 2. So now I calculate 256 minus 192. 64. Oh, that's really nice. So 16 plus or minus the square root of 64 over 2. What is the square root of 64? So I have 16 plus or minus 8 halves. How would I figure that out? 16 plus 8 is 24 divided by 2. X is 12. 16 minus 8 and 8 divided by 2 would be 4, and those are my roots. Do you like that, Aaron? Way better than completing the square? Okay, let's try another one. On this one, I could divide by 2, right? It's divisible by 2, so I could divide by 2 and then plug it in, but just for the sake of using a leading coefficient, we're going to leave it at it as is, and then we'll probably have to simplify in the end. So for this problem, A equals 2, B equals negative 20, and C equals negative 48. So negative B would be 20 plus or minus the square root B squared. 20 times 20 is 400. 400, and then minus 4 times 2 times negative 48. So negative 4 times 2 times negative 48 is 384. So plus 384 over 4. So 400 times, or sorry, plus 384. Is that a perfect square? It is. So it's 20 plus or minus 28 fourths. 20 plus 28 is 48. Over 4 would be 12. And 20 minus 28 would be negative 8. Over 4 is negative 2. Do we like this? Now, you might ask, why did I teach you complete the square if we could have just done this the whole time? And the answer is, we use complete the square in other places where the quadratic formula doesn't make any sense. So you do have to know how to complete the square, but my experience is most people just quit using it. They just use the quadratic formula, which is okay. All right, next one. So A is 1, B is negative 4, and C is 20. So what's that? The third one? Yeah. So negative B is 4 plus or minus the square root of B squared is 16 minus 4 times 1 times 20. So that would be minus 80 over 2 times 1 is 2. Everybody okay so far? So 4 plus or minus the square root of, what is that, 64, negative 64? What is the square root of negative 64? 8i. So this is 4 plus or minus 8i over 2. Now, whenever you have a fraction that has two numbers in the top, you can only simplify if both numbers share that factor. So the question here is, does 2 go into 4 and into 8? Yes. So I can take a 2 out of each of those, which gives me 2 plus or minus 4i all over 1 if you wanted to write it. And those are my roots. Does that make sense? Okay. The fourth one. Can I pull anything out? A 2, so let's go ahead and pull it out. Do I need the 2? Why not? Well, I'm looking for x equals. If I divide by 2, that will change the graph. It will make it from a steep graph to a wide graph, but it will still hit the x-axis in the same place. Divide by 2, and I get 2x squared plus 5x plus 2. So what is negative b? Negative 5 plus or minus the square root of 25 minus 4 times 2 times 2. So that's negative 16 all over 2a in this case would be 4. 25 minus 16 is 9. So negative 5 plus or minus the square root of 9 over 4. The square root of 9 is just 3. So we have negative 5 plus 3 would be negative 2 fourths, which simplifies as negative 1/2. Negative 5 minus 3 is negative 8 divided by 4 is negative 2. Everyone doing okay still? All right, let's look at the next one. Can I divide anything out? No. So 6 plus or minus the square root of 36 minus 4 times 3 times negative 13. No idea what that is. Negative 4 times 3 times negative 13 is plus 156 over 6. All right. 36 plus 156 is 192. Is 192 a perfect square? 160 or 196 is actually 14 squared. So what we need to do is take 192 and factor it. What goes into 192? 4 would. So 192 divided 8, you said? So 8 and 24, 2, 2, 2, 6 and 4, 3 and 2, 2 and 2. What can I pull out? 3 sets of 2. So on the outside, I'm going to get 2 times 2 times 2, 8. On the inside, I have 3. So this equals 6 plus or minus 8 root 3 over 6. Now, anything inside the square root, after you simplify, anything on the inside is going to stay that number. You can never ever pull anything out of the square root. Because it's not really 3. It's the square root of 3, which is like 1.7 or something like that. Okay? So, do these 3 numbers share any factors? They all share a 2. So I can cancel a 2, which is going to give me 3 plus 4 root 3 over 3. And that's as far as you can go. So the only time you can cancel anything in this something plus or minus is if all 3 coefficients share the same factor. So the answer is 3 plus or minus 4 root 3 over 3. Okay? One more. Can I pull anything out of this? No. So 3 plus or minus the square root. 3 squared is 9. Minus 4 times 6 times 16. So negative 4 times 6 times 16. Negative 384 over 2a, which is 12. Everyone understands it up to here? So now 9 minus 384 is 339 a perfect square? Try the square root of 339. Did you get a whole number? No. So we need to factor 339. Just by looking at it, what do I know goes into it? 3 does. So 339 divided by 3 is 3 and 113. What goes into 113? Well, 2 doesn't, 3 doesn't, 4, 5, 6. We should try 7. So 113 divided by 7. But, oh, I did 348. I'm sorry. Sorry, 9 minus 384. Thank you. Okay. 375. What goes into that? So, negative 375. I'm glad you caught that. It's 5 and 75, which is 25 and 3. 5, and 5. Can I pull anything out? What's left on the inside? A 3 and a 5. This 3 and this 5. So that simplifies to be 3 plus or minus 5 I square root 15 over 12. Are there any common factors? Now you might look at it and say 3, 12, and 15 all share 3. But that's not really a 15. It's the square root of 15, which is like 3.8, which is not divisible by 3. So that would be as far as this one goes. Okay, I want you to do the second page today. That's all you need to do is the second page, and then we'll work on this again tomorrow. Quadratic